Kiddos at home. I'm going to go ahead and give you the abbreviated lesson. Kiddos in class did a whole hands-on activity to develop the formulas. I'll explain to you what they did. But like I said, this is going to be an abbreviated version of what happened in class. So what we're working on in 11.6 is spheres. So the first part says, what is named for the shape of an orange? And it's obviously a sphere. Before we jump into this part right here, I just want to go over the anatomy of a sphere. We have this part right here, which is the center. If you ever go from the center to any point on the sphere, that is going to be called a radius. If you go from one point on the sphere across to the other side and you go through the center, that's going to be called the diameter. And then we call this the equator on the Earth, but the equator on the sphere, the math term, is going to be the great circle. Now on Earth, we have a bunch of different lines of latitude, and they're all getting smaller and smaller and smaller. So this would be talking about that biggest one right there. Okay, now for the hands-on activity that the kiddos did in class. First things first, what does the peel of an orange represent? And if it's between volume and surface area, we know that's going to be the surface area. And here is basically the activity that the students did in class. The first part says you have an orange that's been cut as close as possible to the great circle. So I went over and cut the circle or the orange right around here for the kiddos, and I handed it to them. They were then supposed to get a piece of paper and they traced out the cross section of their sphere. So they got a circle, and I had them do 6 of them. So they had 6 circles. It was nothing super special about the number 6. It was just I knew that was more circles than they needed. And then they peeled the orange and they started setting it inside of here. And they filled up one of the circles, and then they filled up the other circle, and they filled up another one, and they started running out of peel, and then they were able to finish by filling up this last one. So that led them to answering these questions right here. It said, what was the shape of the cross section of the orange? And we knew that was a circle. What is the formula for the area of that shape? Well, that's pi r squared. Now, it asked them how many circles they filled up, and they were able to fill up 4 of them. And then when you put all that information together, it gets you the formula. So we know that the peel represents the surface area, and the peel filled up 4 circles, and each circle was pi r squared. So that means the formula for surface area must have been 4 pi r squared. So hopefully that made sense to you guys at home. Now, when you're trying to develop the formula for volume, it's a little bit trickier. Let me explain to you how you do it. So what we've been doing in previous lessons is we'd always go over and look at a figure that was new to us and connect it to a figure that we've already dealt with. So we have already dealt with a pyramid. We know the formula is 1/3 area of base times height. And the idea here is if you put a bunch of pyramids next to one another, you put another one next to that, and you had all of the vertexes touching one another, you would end up with a sphere. Now, yes, I had a student say, well, isn't this base right here flat? And I said, yeah. So that means if you had like 100 of those pyramids, it would be kind of like a sphere, but it would be a little bit not rounded on the sides. But if you push to 1,000 of them, it would get more like a sphere. If you push to 10,000 of them, it'd be more like a sphere. And basically the concept of calc is that you can push as close to infinity as you want until the error does not matter anymore, until it's so smooth that you wouldn't even be able to tell that it was made out of pyramids and not out of like an actual sphere on its own. So what we're going to do is we're going to develop the formula now. For that first pyramid, we're going to call that 1/3 its base 1, times its height. Now, if you were looking at its vertical height and you wanted to know what part of the sphere that was, that's the radius. So the first one is going to be 1/3 base 1 times radius. The next one will be 1/3 base 2 times radius. The next one would be 1/3 base 3 times radius, and so on. what we would do is we'd take out our algebra skills and we would algebra tools, and let's figure out what we can pull out of all of these. We can factor out a 1/3, and we can also factor out an r. And what we'd be left with was base 1 plus base 2 plus base 3, dot, 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 until the last base. At that point, I asked the kiddos in class, I said, what's a different way we could talk about all of these bases together? So if you drew all of these bases, what part of the sphere is that? And they realized that that was just the surface area. So surface area is 4 pi r squared. We already had 1/3 and r over here. And when you multiply those things together, 4 times 1/3 is 4/3 pi. And then you add an r squared and r cubed, and it's going to be r cubed. Sorry, you add an r and an r squared, and that became r cubed. So a good way to remember this is that units for surface area is going to be units squared, hence the squared in the formula. Units for volume is units cubed, hence the cubed inside the formula. So let's go ahead and do some practice problems. On this one right here, we would write out the formula 4 pi r squared and 4/3 pi r cubed. And all we have to do is put our radius in there. So you get 4 pi 10 squared. 4 pi times 100 is 400 pi. And remember, we always leave it in respect to pi unless they ask for a decimal, because that's exact, and exact is always the best possible answer. The next one is going to be 4/3 pi r cubed. 4/3 pi times 10 cubed is 1,000. And how you deal with this is you say that 1,000 times 4 is 4,000 and put it over 3. Now, if that number was divisible by 3, yeah, absolutely divide, but otherwise just leave it like this, inches cubed. So there you go, there's the volume and there is the surface area. And there's obviously no lateral area for a sphere. Okay, what I want you guys to do is I'd like you to pause the video and do this problem, and then check your answers afterwards. Go ahead and pause it. Right, hopefully you've actually paused the video. We know we have 4 pi r squared and 4/3 pi r cubed. So you'd say 4 pi, if that is the diameter, 16 is going to be the radius, and then we would just pop that into our calculator. We do 16 squared, enter, times 4, and that would give us 1024 pi feet squared. Now the next one would be 4/3 pi 16 cubed. At this point you do 16 to the, just a little reminder of how you do that. You say 16 and then you've got your caret button to the third. Now multiply by 4, and that gives us 16384 all over 3 pi. Now if you tried to actually divide this by 3, you would realize it does not divide, so I'm just going to leave it like that. That's feet cubed. All right, hopefully you guys got those two answers. Let's go ahead and look at these harder problems. So on this one, they give us this as 8, but we know that the formulas are 4 pi r squared and 4/3 pi r cubed. And the only way you can do this is if you know the radius. So we need somehow to use this to figure out that side. And we got to figure out, is it Pythagorean theorem, 30, 60, 90s, trig? Well, we know it's 180 degrees for a full triangle, and when we take away the 90, you're left with 90 together. Leftover, I mean. Now, here, every single radius inside this figure is going to be congruent. That means the opposite angles are also congruent. And the only way you could have two angles that are congruent that add to be 90 would be a 45, 45, 90. So now we know what we're doing. The rule here is divide by rad 2. So you have 8 divided by rad 2. Simplify. 8 rad 2 over 2, which is 4 rad 2. That's going to be our radius. So on this problem, you get 4 pi times 4 rad 2 squared, also known as 4 pi, 4 rad 2, 4 rad 2. 4 times 4 times 4 gives me 64. Rad 2 times rad 2 is rad 4, which is just 2. And then you have pi. And that gives you 128 pi inches. Yeah, inches squared. That would be your surface area. Now volume, on the other hand, is 4/3 pi 4 rad 2 cubed. That gives me 4/3 pi times 4 rad 2, 4 rad 2, 4 rad 2. At that point, we're going to do 4 times 4 times 4, which is 64. Rad 2 times rad 2 is 2. And then we have that one leftover rad 2. So it gives me 128. 128 rad 2 times 4/3 pi. And remember, we can just take this, multiply by 4. So 128 times 4 is 512. 512 rad 2 over 3 pi. And 512 is not divisible by 3. Little reminder, you can take your digits, 5 plus 1 plus 2, that's 6, 6 plus 2 is 8, and since 8 is not divisible by 3, 512 is also not divisible by 3. That gives me inches cubed. All right, 2 more problems. So the next one, they give us the surface area, and we need to figure out the radius and the volume. When all else fails in math, all you have to do is draw a picture, and if that doesn't work, since they already gave us a picture, it's write out the formula. So they gave us surface area, which is 4 pi r squared, and that equals 100 pi. So we're going to use this to figure out what the radius must be, so then we can find out the volume. So I'm going to divide by 4 pi, and I'm going to divide by 4 pi, and that gives me r squared equals 25. And when you square root, you get r equals 5. So r is 5. At this point, we can put it into our formula, 4/3 pi r cubed. That's 4/3 pi times 125. 125 times 4 is 500 over 3 pi. And since 500 over 3 pi 500 is not divisible by 3, I'm going to just go over and leave it like that. Gives me inches cubed. Okay. All right, we got one last problem, and that will be the end of the video. So this last one says Earth's moon is 5.25 billion cubic miles in volume. That's interesting. I didn't even say in volume. So yes, this is going to be in, the volume of it, and we want to know the radius. So as I told you, what you can do is when all else fails, just write the formula. Volume equals 4/3 pi r cubed. Now what I'm going to do is I'm going to put my numbers in that I know. I have 5250 000 000 equals 4/3 pi r cubed. Now the r cubed part is going to make it a little tricky. We'll deal with that a little bit later, but right now let's get rid of the 4/3 and get rid of the pi. So I'm going to get rid of the 4/3. You should remember from Algebra 1, you can multiply by the reciprocal. So that gets rid of that. It just becomes 1. I'm going to multiply this side by 3/4. So if I do 5250 000 times 0.75, that gives me 393.75 gives me this, and that's going to equal pi r cubed. Now I'm going to divide, I'm going to leave this in my calculator, I'm going to divide by pi. So divided by pi, that gives me approximately, and you guys should try putting this in your calculator also, it's 125334517 equals r cubed. And this is where you're going to have to remember some stuff from Algebra 1. You should probably remember that to get rid of squaring, you square root. So to get rid of cubing, you do something called cubed rooting. Now the same way that you cube root is raising it to the 1/3 power. So what I'm going to do is I'm going to cube root this, which is just raising it to the 1/3 power, but I don't actually have to do that. And then I'm going to cube root this. And the way you do that, once again, let's say we had 8, the cube root of 8, you would say 8 to the, and make sure you use parentheses. You'd say 8 to the 1/3 power. In this case, it's not 8, it's that big old number. So I'm going to raise that to the 1/3 power, and let's see what it gets me. I'm just leaving the number in my calculator, raise it, and you have to use parentheses or else it won't do the 1/3. It'll raise it to the first power and then divide the number by the number 3. But if you do this correctly, you should get about 1,078 miles. So these are actually the numbers that I got off of Google last night. That is the volume of the moon, and the moon is right around here when it comes to the radius. So just make sure you know how to undo cubing, because we'll actually be doing this in a lesson in just a little bit as well. Okay, most important part of the lesson. We know it's 4 pi r squared for surface area, and it is 4/3 pi r cubed when it comes to volume. And remember, don't go over and round the fraction part. Don't make that like 1,333 pi, because then you're rounding part of the answer, but not all of it. All right, cool. Thanks for watching.